Today we're going to talk about exponential and logarithmic equations and inequalities, section 7.5. So again, we're talking about some equations and how to solve for x when it's in an exponential or a logarithmic function. Okay, so exponential and logarithmic equations and inequalities, section 7.5. First thing we're talking about today is an exponential equation. An exponential equation contains an expression that has a variable as an exponent. For example, if you look right here, 5 to the x power equals 25. Now what's nice about this one is, hey, yeah, when it's a number like this, we know 5 to the what power is 25? X has to equal 2. Yeah, x has to equal 2 here. We know that. Alright? The problem comes in, what happens when I get a problem like this? 6 to the x plus 2 equals 500. Well, 6 to any power doesn't get me to 500. So that's where the problem comes in here, that we have to find a way to solve for x. Alright? So what we're going to do here is when we have x as an exponent, when x is as an exponent, we need to log both sides. So if you look here, we log both sides. Again, think about an equation. What you do to one side, you do to the other side. So I log both sides. Now, what is the reasoning behind logging both sides? We log them because then I can use the power property to pull the x to the front. Remember that power property where we take the power and pull it to the front of the logarithm? That's why we log both sides. So I can take that x and bring it to the front. Now it's a basic algebraic problem, as in I can multiply, divide, add, or subtract and get my answer. So for instance here, I have x plus 2 log 6 equals log 500. I want to solve for x. So I divide right here. So I divide both sides by log 6. So I have log 500 divided by log 6. And then I have x plus 2. Well, how do you move 2 to the other side? You would subtract it. So I got log 500 divided by log 6 minus 2. Now, using your calculator, type that in and make sure you get this as your answer down here. So make sure you're typing it in correctly so you can get that as your answer. You will need a calculator today. Specific. Is that what you're guessing it was, or what? Were you really?
Yeah, no, because I was like, okay, so 6
So yeah, now we're all starting to get 1.468 as your answer. Good work. Alright, so let's look at number 1 here. I have 4 to the negative x equals 32. Notice, my x is in the exponent. Alright, x is in the exponent. So what do I want to do to both sides? I need to log both sides. So I get log 4 to the negative x equals log 32. And what's the reasoning behind the log? So we can bring the exponent to the front. So I have negative log 4, or say negative x log 4 equals log 32. I want to solve for x here. What do I need to do now? Divide both sides by log 4. So I get negative x equals log 32 divided by log 4. Okay. When you do log 32 divided by log 4, what do you get? What did you get? 2.5. So I have negative x equals 2.5. What's the last step I need to do here then? Divide by? I have negative x, so divide by? Negative 1. So my answer here comes out to be x equals negative 2.5. Nice job. Number 2, same idea here. 3 to the 4x equals 90. Notice my x is in the exponent, so what do we need to do? We need to log both sides. So I log both sides, and why do I log it? So that the power comes to the front. So I have 4x log 3 equals log 90. Now what do I need to do next here? I need to divide by what? I could divide by 4, or I could divide by log 3, right? Either one. I technically need to divide by both. I can divide by either one here. I'm going to divide by log 3 first just to get rid of it. Okay? So I have 4x equals log 90 over log 3. Okay, so log 90 divided by log 3 gets me to go to 4 decimals here. 1. Oh, that's my final answer, right? I was gonna say, like, that's not it.
I got 4.0.
0.95, give me one more decimal.
Okay.
9. And now I divide that by 4. And when I divide that by 4, Andy, what's my answer now? 1.0239. Nice job. Again, do you notice if you take your time and kind of work it out slowly with your calculator, you get a lot better answers. If you try and rush it all in there, one equation in your calculator will probably have a misread in there somewhere. Okay? All right, number 3 here. Notice my x is in the exponent. What do I want to do to both sides now? I want to log them. So I log both sides. Give me log 5 to the x minus 3 equals log 600. Awesome. Why do I log it? Because what am I going to do with my exponent then? Bring it to the front. Bring the exponent to the front. Giving me x minus 3 log 5 equals log 600. Great. Now what do I want to do to both sides? Divide by log 5. So I divide by log 5. So I have x minus 3 equals log 600 divided by log 5. What's log 600 divided by log 5? What'd you say it was?
I don't know. It was like 3.97.
So I have x minus 3 equals 3.97, you said? Okay, and what would be the last step I want to do here then? I would want to add the 3 to the other side. Give me x is approximately 6.97. Is that about right?
Yeah.
Nice work. All right, again, the key there is to log both sides to get the exponent out to the front. All right, same idea. Take a couple seconds. Try numbers 4 and 5. So number 4. I have 8 to the 2x minus 5 equals 48. Notice we logged both sides. We pulled the 2x minus 5 to the front. What would be my next step here, Melody? What would I want to do next?
Like both sides.
Yep, so I divide both sides by log 8. So I get 2x minus 5 equals, what's log 48 divided by log 8 to 4 decimals? 2 point what? 160. And then what do I want to do next there? And then I'd want to add 5. So I get 2x equals 7.160. And then I would divide by 2. And I get x comes out to be approximately, what is it, Maddie? 3 point what? 5.8. There you go. And again, if you don't round early, you get more of a precise answer. Probably a little bit different decimal there. But those are all approximate answers. Number 5. Add 4 to the x plus 2 equals 20. Notice what I do to both sides. I log them. Why do I log them? Because I'm going to pull my exponent to the front. When I pull the exponent to the front, what do I get, Andy?
You get x plus 2 log 5.
So what am I going to do next then, Andy? Divide by log 4. Now, somebody earlier was like, can I just simplify that right away and give me log 5? Notice that's not the same thing here. Okay, log 20 over log 4 is not the same thing as saying just log 5. Okay, so notice that is not the same. So I have x plus 2 equals log 20 over log 4. And then what is the last step I want to do here? Andy, I'd want to subtract 2. And what do you get for an answer, Andy? X comes out to be approximately what? 2.1609 is correct. Nice job. All feeling pretty good about those? Good. Last thing we're talking about today now is what happens if it's a logarithmic equation. For example, a logarithmic equation contains a logarithmic expression that has a variable. For example, log base 5 of x equals 2. Okay, so logarithmic equation now I'm given the log here. When I'm given the log, I want to change it to an exponential equation. So how would I change this to an exponential equation? Well, I'd bring my base across. I'd sweep my base across, giving me x equals 5 squared. Well, what's 5 squared? What is it? So x equals 25 on that problem. Okay, so when I have a logarithmic equation, I sweep the base across in order to solve it. Logarithmic equations can get a little bit tougher. Why? Again, because I'm looking at properties. Need to remember my properties. So for example here, let's look at log 80x minus log 4 equals 1. Anytime I have subtraction, what property is that? That is my quotient property. So quotient property says I'm going to divide them, to simplify them, by division. 80x divided by 4 gets me log 20x equals 1. So I'm on step 2 there, log 20x equals 1. Now, what is the base of this logarithm? This is my common base. Who remembers what the base is for the common base? It is base what? 10. Yeah, common log is base 10. So what am I going to do with that 10? I'm going to sweep it across. When I sweep it across, I get 20x equals 10 to the first power. 10 to the first power gets me what? 10. So I have 10 equals 20x. Divide both sides by 20. And I get x comes out to be 1/2. Okay, so when I have a logarithmic equation, I want to put it as an exponent, or an exponential equation. So I'm sweeping it across. So let's try number 6 here. I have log base 3, x to the 4th equals 8. Notice, what they do with this exponent? They brought it to the front. Okay, so I brought the 4 to the front. And then what they do, they divided by 4 on both sides to get just my logarithm alone over here. So that gives me log base 3 of x equals 2. Okay. Now, what am I going to do with that 3? I'm going to sweep it across, giving me x equals 3 squared. 3 squared comes out to be 9. X equals 9. Nice job. Okay. Number 7. A little bit tougher on number 7. Why? Because I have to combine them with a property. What property is based on addition here? What property would that be? That would be the product property. So I'm going to have to multiply these. So I get log 4 times x plus 2, which gives me 4x plus 8 then, because I just distributed it. What am I going to do with that 10? I'm going to sweep it across. So I get 4x plus 8 equals 10 squared, or 4x plus 8 equals 100. Because that's that common log. Yeah, because there is no log, so if there is no log, that's the common log, always base 10. Good question. So now I have 4x plus 8 equals 100. What do I want to do next here? I'd want to subtract 8. Give me 4x equals 92. And then I would divide by 4. And I get x equals 23. Nice job. Let's try number 8 here. So notice I have log base 2, x to the 7th equals 21. What do we do with that 7? We pull the 7 to the front. Why do we pull it to the front? Because then I can divide both sides by 7. I get log base 2 of x equals 3. 21 divided by 7 is 3. What am I going to do with this 2 then? I'm going to sweep it across, giving me x equals 2 to the 3rd power. What's 2 to the 3rd power? X comes out to equal 8. Nice job. 9. What property am I looking at here? The quotient property, division 1. So I combine them to a single log based on division. So I get log 75x over 3 equals 1. What's 75 divided by 3? So I get log 25x equals 1. Now, there is no base in this log, so it's a common log. What's my base? My base is So I sweep the 10 across. I get 25x equals 10 to the first. 10 to the first power is nothing more than 10. So 25x equals 10. Divide both sides by 25. X comes out to equal what? 0.4 or 2/5, either way. Nice job. Take a couple seconds, try these two on your own real fast. Alright, so let's walk through number 10. Phil, what was the first thing you did?
I took the 3 over.
Great. So you had 3 log base 5x equals 15. What did you do next then, Phil?
Divided both by 3.
Divided by 3. So you had log base 5x equals 5. What did you do next, Phil?
5 and 5.
Not divided by 5. You want to move the 5 across to exponential form. So that's x equals 5 to the 5th power. And then 5 to the 5th power gets me anybody? 3,000, is it 125? 3,125, nice job. 11, you have to think of property here. What property deals with subtraction? It is the quotient. So I have log x over 9 equals 3. Andy, what would you do next? So I have log x over 9 equals 3.
Yeah, and then the logs mix up, and then you have x over 9 is 3
Before you do that, what you have to do is you have to do the log base here. Yeah, sweep the base across, don't you? So you have x over 9 equals 10 to the 3rd power. What's 10 to the 3rd power?
10,000.
So I have x to the 9 equals 1,000. And now I need to do what to both sides? Multiply by 9.
Exactly 9,000.
I get x equals 9,000. Nice job. Here's your assignment.